Hi students, welcome to SSJI Chemistry. If you are preparing for mains, AIIMS and NEET, this channel is very helpful and I'll give insurance for mains, AIIMS and NEET. If you follow each and every video, I'll give insurance for mains, AIIMS and NEET. Okay, today we will see some previous year's questions. First question, in which of the following process the bond order has increased? The bond order has increased and magnetic nature, paramagnetic character has changed to diamagnetic. Again question once more I am repeating. In which of the following process the bond order has increased? Bond order has increased and paramagnetic character changed to diamagnetic. Paramagnetic character changed to diamagnetic. These are the options. Okay. First of all, we'll see about bond order and magnetic nature. Paramagnetic or diamagnetic they don't know. So is there any tricks behind the bond order and magnetic nature? Of course, it is there. For bond order, first of all, we will see for bond order trick. Bond order trick. Bond order trick. Okay. First of all, we should count the electrons. Okay. First step is we should count the electrons. Then, if we count the electrons, if it is 14, then the bond order is 3. If it is 14 electrons, then the bond order is 3. If it is 13 electrons means 2.5. 12 electrons means 2. Okay, 11 electrons means 1.5. 10 electrons means 1. 9 electrons means 0.5. 8 electrons means 0. Okay, these are the electrons, number of electrons. 8 electrons, 0 bond order. 9 electrons, 0.5 bond order. 10 electrons, 1. So these are the bond order, these are the electrons and these are the bond order. Okay, and if it is a 15 electrons, then here also it is decreasing. 15, 16, 2, 17, 1.5, 18, 1, 19, 0.5, 20, 0. Okay, what is the bond order trick? First of all, we should count the electrons. If it is 14, then it is 3. Okay, always remember for 14 it is 3. And if you observe above, it is gradually decreasing 0.5 and below also it is decreasing gradually 0.5. So this is the bond order trick. Okay, these are the number of electrons. Number of electrons. This is the bond order. This is the bond order for that number of electrons. Okay. Next, magnetic nature trick. Is there any trick behind magnetic nature? Of course it is there. Magnetic nature. For magnetic nature also trick is there. If we count the number of electrons, then if it is even number, then it is a diamagnetic nature. If it is an even number, then it is a diamagnetic nature. If it is odd number, then it is paramagnetic nature. First of all, for magnetic nature also we should count the electrons. If we count the electrons, if it is an even number, then it is a diamagnetic nature. If it is an odd number, then it is a paramagnetic nature. Okay? Okay. But for exception is, if we count the electron, for exception is 10 electrons and 16 electrons. Okay, 10 and 16 is even number, so it should be dia. But for 10 electrons and 16 electrons, it is paramagnetic. For 10 electrons and 16 electrons, it is paramagnetic nature. In maximum cases, this is the trick for magnetic nature. Okay, this is the for bond order trick. Okay, okay. Coming to this, O2 means how many in O2? These are the options. So we'll go one by one. O2 means 2 oxygens. In one oxygen, 8 electrons are there, but here 2 oxygens. So how many electrons? O2 means 16 electrons. So 16 electrons means it is a paramagnetic nature. So it is a paramagnetic nature, and 16 electrons bond order is 2. So paramagnetic nature and bond order is 2. Okay. O2 means 16 electrons and O2 plus is 15 electrons. O2 plus is 15 electrons. 16 means dia. So 16 electrons means exceptional case is there. So paramagnetic. And how many bond order is 2? For 16 electrons bond order is 2. Okay. O2 plus 15 electrons. If it is in 15 electrons means odd number. Odd number means paramagnetic nature. Paramagnetic nature, and 15 electrons, for 15 electrons bond order is 2.5. Okay, 15 electrons bond order is 2.5. See, question, paramagnetic, it should convert paramagnetic to diamagnetic, but here you can observe it is not converting to paramagnetic nature to diamagnetic, because para to para, it is both are para nature, paramagnetic. So this is not correct. This is not correct. Next, O2 to O2 2 minus. In O2, how many electrons? 16 electrons. Paramagnetic nature. Bond order is 2. Bond order is 2. O2 2 minus. O2 2 minus. O2 2 minus means O2 means 16 electrons. 2 minus means we are adding 2 electrons. So 16 plus 2, 18 electrons. For 18 electrons means even number. Even number means diamagnetic. So it is diamagnetic. And 18 electrons means bond order is 1. Bond order is 1. Here you can observe paramagnetic to diamagnetic. Yes, it is converting paramagnetic to diamagnetic. But bond order should be increases. But here you can observe bond order is decreasing. So this is also not correct. Actually, it should satisfy two reasons. Bond order should increase. Here bond order is decreasing. That's why it is not satisfying that. So it is not the correct. Okay. Next, N2 to N2 plus. N2 means how many electrons? Nitrogen means 7 electrons. So 2 nitrogens are there. So 14 electrons. So 14 electrons means even number. So diamagnetic nature. And how many bond order is? Bond order is 3. For N2 bond order is 3. 14 electrons are there. So it is bond order is 3. N2 plus means if we remove an electrons, so we will get positive charge. So N2 means 14 electrons plus charge is there. So 14 minus 1. We are removing 1 electron. So 14 minus 1 means 13 electrons. Okay. 13 electrons means it is a odd number. So paramagnetic nature. Odd number. So paramagnetic nature. 13 means 2.5. Okay. So here also it is not satisfying this question, paramagnetic to diamagnetic, but here diamagnetic to paramagnetic is there, so it is not correct. So option 3 is also fails. Next, option D, NO means nitrogen 7 electrons plus oxygen 8 electrons, total 7 plus 8 15 electrons. So 15 electrons means it is an odd number, so it is a paramagnetic nature. It is paramagnetic nature, and its bond order is for 15 2.5. For 15 2.5 is the bond order. Next, NO plus means for NO we got 15 electrons. Plus means we are removing 1 electron. So minus 1. 15 minus 1, 14. 14 means it is an even number, diamagnetic nature. So, and bond order is for 14 bond order is 3. So here you can observe what is the question, bond order should increase. Here you can observe 2.5 to 3. So bond order is increasing, and paramagnetic character has changed to diamagnetic. You can observe here paramagnetic converting to diamagnetic. So this is the answer. Okay. So this is the bond order trick and magnetic nature trick. In maximum cases it satisfies. Maximum cases. Okay, 99.99% it satisfies. Okay, please note down. Okay, second question. The second question is the type of hybridization and number of lone pairs of electrons of xenon in XeOF4 respectively are. What they are asking? They are asking about hybridization and lone pairs. Is there any trick behind the hybridization? Yes, it's there. For hybridization, there is a trick, and I have already discussed about the trick of hybridization. In description, it is there. Link is there for hybridization trick. Okay, now we will go. XeOF4. Okay, XeOF4. First step, what is the step 1? We should find out the central atom. Here, what is the central atom? Xenon. Xenon is in neon family. So we should consider the neon atom. Neon atom atomic number is 10. Atomic number minus 2. Okay, atomic number minus 2. So atomic 10 minus 2 equal to 8. So we should take 8 dots. We should take how many dots? 8 dots. So now I am taking 8 dots. And here what are the side atoms? So here the side atoms are oxygen and 4 fluorines. So we should connect for oxygen. If oxygen is the side atom, then we should connect 2 dots for oxygen. 2 dots for oxygen. For remaining everything we should connect with 1. So fluorine. Okay, each dot is connecting with fluorine. 4 dots are connected with fluorine. For if oxygen is a side atom, then we should connect 2 dots for oxygen, and remaining 2 dots are there left. So we should round up that 2 dots. Count that numbers 1, 2, 3, 4, 5, 6. 6 is there. 6 means sp3d2. If the count number is 6, then it is sp3d2 hybridization. And how many lone pairs are there? These are the lone pairs. These are the lone pairs. How many lone pairs are there? 1 lone pair left. 1 lone pair is there. 1 lone pair, 5 bond pairs. And count number is 6. So 6 means sp3d2. So sp3d4 means 6 sp3d2 with 1 lone pair. sp3d2 with 1 lone pair. So option C is the correct. Okay. Please note down this. And if you want hybridization details, have in the link is there in the description. So please go through that. Okay, next third question. The correct shape and I means iodine bond angles respectively in I3 minus ion are. They are asking about bond angles. Okay, what are the shapes? And shapes also they are asking. Distorted, trigonal, planar, and 135 and 190 degrees. These are the options. Okay, so we'll go with hybridization for to get the shape and bond angles. I3 minus. So I3 minus means I am writing this as I into I2 minus. I into I2 minus. Here iodine is the central atom. Iodine is the central atom. So iodine is which family? Fluorine family. So fluorine atomic number is 9. So 9 minus 2, 7. So how many dots we get? We should take 7 dots. We should take 7 dots. 4, 6, 7. But here what is there? Minus charge is there. Minus charge is there. Minus 1 is there means so we are adding 1 electron. So we should add 1 dot. So how many dots are there? 8 dots are there. So we are connecting with 1 dot with. So these are the two iodines are the side atoms. So 2 iodines are the side atoms. So iodine. So these 6 dots are left. 6 dots are left. So these are converted into lone pairs. How many lone pairs are there? 3 lone pairs. So count this 1, 2, 3, 4, 5. So 5 means sp3 dehybridization. sp3 hybridization with 3 lone pairs. sp3 hybridization with 3 lone pairs. sp3 dehybridization with 3 lone pairs means which shape it is? Linear. And what are the bond angles? 180 degrees are the bond angle. So linear 180. So linear 180 means option D is the answer. Option D is the answer. Okay, next fourth question. Total number of lone pair of electrons in I3 minus ion is. Total number of lone pair of electrons in I3 minus ion is. So this is the I3 minus structure. What is this? What is the bond angle? 180 degrees bond angle is there. 180 degrees and linear shape it is. Okay. So now they are asking about lone pair. How many lone pairs are there? So count this 1, 2, 3, 4, 5, 6, 7, 8, 9. So total in I3 minus total 9 lone pair of electrons are there. So option D is the correct answer. Okay. Question number 5. Which of the following species is not paramagnetic? Which of the following species is not paramagnetic? Options. These are the options. Okay, they're asking about magnetic nature. So we have one trick. If first of all we should count the number of electrons. We should count the number of electrons, and if it is even number, then it is diamagnetic. Even number, then it is diamagnetic. If it is odd number, then it is paramagnetic. Okay. First of all, we should count the number of electrons. If the number of electrons are even, then it is diamagnetic. If the number of electrons are odd, then it is paramagnetic nature. Okay. But what is the exception? Exception is for 10 electrons and 16 electrons. 10 electrons or 16 electrons are there, then it is paramagnetic nature. Then it is paramagnetic nature. So first of all, we should count the electrons here. Option A, NO. NO means how many electrons? N means 7 plus oxygen means 8. 7 plus 8, 15. 15 electrons. 7 plus 8, 15 electrons. 15 electrons means paramagnetic. Odd. 15 electrons means odd number. Odd number means paramagnetic. Okay. Here what the question is? Not paramagnetic. But here it is a paramagnetic. So option A is wrong. Next, CO. CO means 6 plus oxygen 8. 6 plus what is the oxygen? 6 plus 8 means how much? 14. 14 electrons means it is diamagnetic. Okay, they are asking about not paramagnetic means diamagnetic. So CO is the correct option. CO is the correct option. Okay, we will see for O2 and B2 also. For O2, how many electrons are there? 16 electrons with one oxygen, 8 electrons. So here 2 oxygens are there. So 16 electrons. 16 electrons means paramagnetic nature. 16 electrons means paramagnetic nature. Next, B2. B2 means 10 electrons. Boron, 5 electrons. So 2 borons are there. So 10 electrons. So 10 electrons means paramagnetic nature. So here only diamagnetic is CO. So option B is correct. Okay. Okay, you want to know something about chemistry? In chemistry, in the periodic table, the only letter that doesn't appear in the periodic table is J. We cannot see letter J in the periodic table. Okay? If you like this video, please share and subscribe, and please comment also. And if you want more videos on some topics, please give information in the comment box. Okay? Thanks for your patience and thanks for your support. And sometimes I will ask challenging questions also. Please respond for challenging questions also. Okay? Thank you. Please share and subscribe and comment. Thank you.